So I can delete this. Come on, delete. Oh, sweet. Yay. All right, hello. Just continuing our idea of complex numbers or imaginary numbers. I guess complex means there's a real part, imaginary part. Wow, a real part, imaginary part. So I think I'm doing 33 through 63 odd. Yikes. Okay, no, I got it. No big deal. Ripping through these. It's going to be simple. Well, it's going to be okay. All right, so 33, we got 2i over I plus 1 plus I, man. There we go. Kind of the idea is, it feels like you can't do anything here, but it was real similar to in algebra when you had, a square root in the bottom, and then you're taught to rationalize the bottom. And like traditionally, you want, we were taught, multiply by the, by itself, the top and the bottom, and, you get a perfect square down there, and then you can get rid of the square root. But we're going to use the idea of that whole like a squared minus b squared factors into a minus b, a plus b, so that we can get a difference of two squares. Because if we square everything, then we're not going to have an imaginary number. The imaginary number kind of goes away. So I got 1 plus I times 1 minus, 1 minus I. Because of the identity property, if I multiply to the bottom, I have to multiply to the top. 1 minus I. And then I'm just going to do math. So I'll distribute on top. So I'll get 2i minus 2i squared. And then on bottom, again, when I FOIL that out, the middle terms are going to cancel out. So I'll get 1 minus I squared, if I did that correctly. And then I'm going to simplify just a little bit more. I'll write this as 2i. Minus I squared is negative 1. But there's already a negative there, so this is going to be a plus 2. Again, I squared is negative 1. I is equal to the square root of negative 1, so I squared should be equal to negative 1. I hope that makes sense. Continuing, no big deal. Onto the bottom, this will turn into negative 1 as well. But we already have a minus that, so they'll just turn into a 2. 1 plus 1 is 2. I'm going to rewrite this. Usually speaking, in terms of a complex number, we always write the real part first and then the imaginary part second. So it would be 2 over 2 plus 2i over 2. Simplify just a little bit, and we get 1 plus I. No big deal. It's an easy problem. This is just like mechanics. There's not like a ton of thinking here. I guess like the fraction part you can kind of mess up on. All right, 35. Let's see, I think that's a 5i. 5 plus I over 3i. I feel like this one's even easier. Again, I is a square root. You can't have a square denominator and say it's still simplified. So we want to rationalize, which becomes a skill we use a lot later. It's like this whole like, can't have a square root on the bottom. I feel like the only reason we say that is that we develop the idea of rationalizing. Later on, you'll actually rationalize the numerator, which becomes interesting. All right, so I'm going to go ahead and distribute. So here's 5i plus I squared all over 3i squared. Same as before, I'm just going to, square that. I should get negative 1. I don't know why I wrote that way. And on the bottom here is going to be negative 1 as well. You have a 3 out there, so this is negative 3. I'm going to write this as two separate fractions, the real part and the complex, or the real part and the imaginary part. And so this should be 1/3 minus 5/3 I. That's no big deal. Again, the negative 1/3, the negative 1 and the 1/3 will turn positive. On to the next. Yay. Getting through this as quickly as possible, but still try to not be careless. There we go. Solve each problem. I'm going to solve this by factoring. Maybe I'll do both ways. You know what? I don't know. Let's see, 3x squared. You know what? I bet you they want us to solve this not by factoring it. I'm going to go ahead and solve. Is x by itself? No. I'm going to subtract the 48. I'm going to divide by 3. And then I'll take the square root of both sides. I think we had this conversation before. When I take the square root of x squared, that actually turns into the absolute value of x. I'm going to rewrite this. This will turn into 4i. And the reason why, this is really the square root of -1 times the square root of 16. Square root of 16 is 4. The square root of -1 is I. So you have the absolute value of x is equal to 4i. Or if we want, x is equal to plus or minus 4i. Done. Is that it? Check our work. Check our work. Well, I mean, as a good math student, you should be checking your work. So let's take one of the solutions. So 3 times 4i quantity squared plus 48. Let's see, that's 16i squared times 3. So this should be 48i squared plus 48. But I squared is just -1. So you get -48 plus 48 is equal to 0. And that's what we're looking for. It is a true statement. It does work. I think that's really the nice thing about algebra is like you can always check your work. You always check your work. Especially when we're like solving equations. All right, 39. That'll probably be the last time I check my work though. I got 2x squared plus 10 equals 0. I'm going to go ahead and solve this. So I'll say 2x squared is equal to -10. X squared is equal to -5 when I divide both sides by 2. And skipping some steps, I'll get x is equal to plus or minus the square root of -5. But that's plus or minus the square root of -1 times square root of 5. Square root of 5 is not big enough to come out of the square root, so this turns out to be the square root of 5i plus or minus. We technically write, when we're working with square roots, we technically write the imaginary part like that. But it doesn't matter. Same thing. All right, number 41. Yikes. I don't know if I can divide that. Guessing 16. Yeah. So I'll get 8x squared plus 128 is equal to 0. I'll get 8x squared is equal to -128. I'll get x squared is equal to -128 over 8. I believe that's 16. Just don't know how to show that. I'm just fooling around with this. You know, I feel like a lot of people know powers of 2, like 2, 4, 8, 16, 32, 64, 128. So I think 128 is 2, let's see, 32 is 2 to the 5th, 64 is 2 to the 6th, 2 to the 7th should be 128. Okay, divided by 2 to the 3rd. All right, remember when we're dividing exponents, we keep the base and subtract the exponents, the powers. So we get -2 to the 4th. I guess this whole thing's negative like that. And this just turns 2 to the 4th is just 16. So we got -16. So x is equal to plus or minus the square root of -16. And then I just break this up into an imaginary part and the real part. And so I'll get plus or minus I when I get the square root of -1. Okay, this part we write like that. Square root of 16 is 4. The square root of -1 is I. And like I force, it is kind of weird. Math is kind of weird, but like we tend not to write it like this. We tend to write it like that. Oops, hold on. Anyway, yeah, but when we're talking about numbers, we don't write like I4. I mean, you could. I times 4, we write it as 4I. We'll get used to it. That's no big deal. Okay, so on to 43. Okay, I think these ones are going to get harder. Let's see. So I got x plus 1 plus 2yi is equal to 3 minus 6i. Okay. That's not bad. All right, this is a complex number. Assuming x and y are real numbers. Can we make that assumption? Screw it, I'm making that assumption. All right, so this part of the complex number is real. and this part of the complex number is imaginary. And this part is real, and this part's imaginary. And so you align coefficients. We may have talked about this, I don't really know. But I'll say x plus 1 is equal to 3. And I'll say 2y I is equal to negative 6i. I have two equations. And I believe we're trying to find the values of x and y. So on solving this one, you get x is equal to 2. And solving this one, you get divide both sides by 2i. 2i. And you get y is equal to negative 3. Yeah, negative 3. That's not bad. And you're like, man, I don't believe you. Well, then plug the 2 in. You'll get that 3. Plug this negative 3 in, and you'll get that 6. It's not bad. It's pretty chill. I mean, it's like maybe interesting the first time you've seen this, the whole aligning like coefficients, but at some point it's real easy. All right, on to 45. Just ripping through this. This might be a quick video. 5 plus y plus 3x minus 7i equals 9 minus 3i. All right, same as before. Okay, now, yeah, same thing. This is this right here. I'll take a different highlighter color. This right here is the imaginary part, and this part here is the real part. So we're going to line the real part with the real part. So 5 plus y on the left-hand side has to be equal to 9. I hope that makes sense. Like, it's like if you have the real part on the left-hand side, it has to be equal to the real part of the right-hand side. And the imaginary part on the left-hand side has to be equal to the imaginary part on the right-hand side. And then we just solve, like whatever this works out to be. This is easy enough. This is just y is equal to 4. No big deal. Again, we're solving for x here, so I get 3x is equal to, I'm going to add 7i, so I got negative 3i plus 7i, which is 4i. And then finally divide both sides by 3. I got x is equal to 4/3 i. Oops. Good question. Good question. Oh, I was being silly. There should have been parentheses here. Yeah, I messed up. All right, there should be parentheses there. And the reason we want those parentheses is I would probably first thing divide both sides by I. Divide by I, divide by I. You get 3x minus 7 is equal to negative 3. Yep. And then you get 3x is equal to 4. And then x is equal to 4/3. All right, not bad. Not bad. On to 47. 47. I get 2a minus 4bi plus a plus 5b is equal to 15 plus 58i. Okay, like at some point this is just busy work. I think we're at that point. Maybe. Again, I'm gonna set up two equations. This is the real part of the left-hand side, and this is the real part of the right-hand side. So I have a plus 5b is equal to 15. And then I set up my second equation. This is the imaginary part, and this is the imaginary part. I'm going to go ahead and get rid of the i's. So just imagine the coefficient, because I could divide both sides by I. But I'm going to have this equation here. 2a minus 4b equals 58. My b's look weird. My 15 looks like an I5. I don't know. Let's see. There we go. All right. And then, surprise, surprise, we have a system equation. We're trying to find a and b. We have two variables. We have two unknowns. Like, you know, whatever you're comfortable with. I feel like, in my opinion, I'd probably multiply this by negative 2. And when I multiply that by negative 2, I'll get negative 2a minus 10b equals negative 30, if I did that correctly. I'm hoping I did. Excuse me. And I'll just add that up, and hopefully things work out. So it looks like we'll get a negative 14b after these guys cancel out. And then this is equal to, looks like a positive 28. Uh-oh. Did I mess up? Can't tell. Okay, so b is equal to -2. No, I think that looks right. That looks right. You know, no big deal. Seems doable. I'm not done. I'm like halfway done though. I have the b value. Now you go find the a value. Okay, so pick one of the equations. I don't know. I guess I'll pick this. A plus 5 times -2 is equal to 15. And then you get a minus 10 is equal to 15. So a is equal to 25. And then all good math students, check the work. Yeah. Sure, it works. I hope. All right, on to the next. 49. Oh my God, that looks not so fun. Is that a 4i times 1/2 I squared? Oops, I squared times. Oh, there you go. I feel like I'm gonna mess up on this. Not that it's hard, but just like a lot of places to make a mistake. All right, so I'm gonna, order of operations, we have to do exponents first. So we'll say 4i times, when I square 1/2 I times 1/2 I get 1/2, I'll get 1/4 I squared, but I squared is -1. So this will turn into -1/4. Easy enough. And then on this guy, this is -2i times -2i. That's what means to square something. So I believe you'll get positive 4i squared, but I squared is -1, so this just turns into -4 times -4. Seems right to me. These guys are going to cancel out, and you'll have a negative times negative, which is a positive, and this will all turn into 1, and you just get 4i as your answer. It's whatever. It's not bad. I get 51. 51. What? I'm not sure what we're supposed to do here. Let's see. 4 minus 6i plus 4 plus 6i. Okay, so with complex numbers, you do have the commutative property and the associative property, and we could regroup and change orders and stuff like that. I guess provided that this wasn't subtraction, so you have an over addition. So I can regroup and using the commutative property and associative property, I'd get 4 plus 4 plus -6i plus 6i. And the -6i plus 6i, well, that's just 0. And then 4 plus 4 is just 8. Done? I guess so. Oh, shoot. All right, on to 53. Hold on. Okay. Shoots. Yeah, it's crazy at the house right now. But I'm finishing. And we're already at 18 minutes. So 53. Okay. So I got -6 minus I times 3 minus 3i, if I did that correctly. I'm going to go ahead and distribute, FOIL, whatever you're comfortable with. This is -18 plus 18i minus 3i plus 3i squared. And then I'm going to combine like terms and stuff like that. Let's see, so I got -18 plus 15i minus, okay, so I squared is -1, so this is going to be -3. And then I'll get -21. Sounds right. -21 plus 15i. That's not a big deal. All right, on to the next. I just got tired all of a sudden. All right, 55. 6i over 2i minus 3i. Again, I'm going to multiply by the complex conjugate. It uses that difference of two squares idea. So we got 2 plus 3i and 2 plus 3i. All right, and then I'm going to FOIL at the top, FOIL at the bottom, and good things going to happen. Feels a little busy work, but let's finish strong. Let's see, 6 times 2 is 12. 6 times 3 is 18i. This is negative 2i. And then finally, negative 3i squared. On the bottom, when I do the math, again, because of difference of two squares, the middle terms are going to cancel out, and it's the first term minus the second term squared. So it's going to be like 4 minus 9i squared. Simplify further. 12 plus 16i. This turns into negative 1. This is plus 3. All over 4. This will turn into negative 1, but there's a negative there, so plus 9. Yeah, dude, I can't pay attention. There's like too much stuff in the background. All right, so I say 15 plus 16i all over 13. Let's just make sure we got this, 13. And then I'll rewrite it as the real part plus the imaginary part. And we're done. On to 50, was that 55? I think so, on to 57. Like, dude, I get, like, the theory about 57, but at some point it does become busy work, but I don't know. Because what doesn't kill us? Make us stronger or something? I don't know. Maybe there's a trick. I don't know. Let's see. 1 plus I times 2 plus 3i times 4 minus 3i. I don't know. Remember when we multiply, we have to multiply two things at once. Wait, two things first. And then that result we're going to multiply by. So I'm going to carry this I plus 1 along for the ride. And then we got, first times first, which is 8. Outside times outside is negative 6i plus 12i minus 9i squared. And you get 1 plus I. And this is going to turn into positive 9 because negative, I can't even think, I squared is negative 1. But there's already a negative, so this turns into positive 9. 9 plus 8 is 17. Minus plus 6i. When I combine those two, it's not so nice. The numbers are kind of weird, but it's not impossible. Like, I guess I'd rather have a problem like this than like a honors problem with like sprinkles of honors on it. I don't know what the saying is, but anyways, I'm going to continue here. So this is 17, and this will be plus 6i, and this will be 17i, and then finally we get plus 6i squared. This is going to turn into negative 6 because of the I squared, and you have a 17 out there, so there's an 11. Plus 6 plus 17 is 23i. I guess, looks good. Looks good. 59. I only have a few minutes left. Let's see if we can finish this. So I got 2 minus I squared of 3 over 2 plus I squared of 3. Interesting. I feel like there's going to be something cool here, but I'm just going to continue. I'll multiply by the complex conjugate. Boom, boom, boom. And then 2 minus I rad 3. Boom, boom, boom. And then I'll just FOIL everything out. On the top, when I FOIL, it'll be 4 minus 2I rad 3. So that's 2I rad 3. And this is going to be minus 2I rad 3. And then finally, the last term is plus, is that an I? I'm so confused. Yes, it's an I. Plus I squared rad 9. Okay, so let's simplify the top and the bottom. Again, on the bottom, it's going to be a difference of two squares, so it's going to be like 4 minus I rad 3 squared. All right, simplifying the top further. this is going to turn into -3. And the reason why, the square root of 9 is 3. I squared is -1, so this is -3. So you have 4 minus 3. Yeah, 4 minus 3, which is 1. And then you have 2 of these guys. You know, there's 2 of them. So there should be -4i rad 3. All over. Let's see if we can do the bottom here. Guess I'm going to do it in steps. This will be I squared. And then you're going to get 3, because the square root of 3 squared is just 3. And this is 3i squared. So you get like 3i squared. If I squared is -1, so this just turns into -3. But there's already a negative out there, so this will be +3. And we'll get, breaking this up into the real part and the imaginary part, we'll get 1/7 minus 4i rad 3 over 7. Whatever. I mean, it's not terrible, you know. It's not. It's okay. It's okay. It's okay. 26 minutes. I got 4 minutes. Again, my goal is to get all homework under 30 minutes. Otherwise, the homework's too long. Let's see. The current in a circuit is 3 plus 6i 6j amps. Good night.
Good night.
Or later, dude. And the impedance is, I don't know what any of that stuff means. I did take electric and magnetism as a, calculus level physics course, but man, it's been way too long. All right, anyways, they give us a formula. They say, like, to find V, which is the voltage, you take the current, which is C, and you multiply by the impedance. I don't know. The resistance? I don't know. I thought it was resistance, but who knows? All right, so I'm multiplying, basically using this formula. And so we want the voltage is equal to, and they give you the current. They say the current is 3 plus 6 J amps. No idea. All right, times the impedance or resistance. I thought that was always a resistance thing. Okay, resistance 5 minus J. And then do stuff, normal stuff. So I'm going to go ahead and FOIL this out. I don't know why this is a problem here, but I'm going to continue. So I get 3 times 5, which is 15, and 3 times J is -3J, and then this is plus 30J, and then finally minus 6J squared. And I'm guessing the J is like an I, and so it'll turn into -1. So you get 15 minus 27J plus, okay, so there's -1, so you got -1 times -6, which is just +6. So you get 21 minus 27J volts. I think we end up with volts. I don't know. I wouldn't. And we're just multiplying stuff. Anyways, oh my god, I got 1 minute left. I have one problem left. Find the sum. Why does this look oddly impossible here? 4 plus 5ix plus 7. And we want to add it to 3x squared plus 2 plus 6ix, and then minus 8i. Okay, I got it. And I still got 30 seconds, so I'm going to add these two. But they're not like terms, so the only way I can add this is saying 3 plus I times x squared. I hope that makes sense. I kind of like factored out the x squared and just have this. And on the next one, I I'm gonna put a plus here. And then this is like a -4, but this is a +2, so I'm gonna put -2. And this is a -5i, and this is a plus, and so I'm gonna put this as a plus ix. And then I have a +7, and then a -8i. Yay. I'm done. I'm done. That's it. Not very interesting.